Okay, so in trying to match the graphs of f of x and h of x to the 6 graphs that we have here for options, one thing we could do is we could try to look at the x-intercepts and maybe y-intercepts if it's helpful. And so an x-intercept is just where the graph crosses the x-axis. Likewise, a y-intercept is where the graph crosses the y-axis. So you can find a y-intercept by plugging in 0 in for x. So if I plug in 0 here, 0 to the third, negative 0, that's just 0. And 4 times 0 squared, that's 4 times 0, that makes 0. So if you plug in 0 in for f of x, you should get 0 for y of x. That means the graph of f of x, it has to have a dot here at the origin. And so that rules out A, it rules out B, that these two can't be f of x. C could be f of x because it has a dot at the origin. D could be f of x, E could be f of x. So it's C, D, or E for f of x because those are the ones with dots here at the center at the origin. And so if you try h of x, it's kind of harder to find, we can still find the x-intercepts. If you plug in, the y-intercepts. If you plug in 0 in for x, here you got 0 minus 3 squared. And then you got 0 squared minus 1. So 0 minus 3 is negative 3. Negative 3 squared is 9, positive 9. And then 0 squared is 0. 0 minus 1 is negative 1. So you get 9 times negative 1. You should get out negative 9. Okay, so we don't know what h of x looks like, but we know it has to have a dot at 0 on the x and negative 9 on the y. And so you can see how that could rule out some of our other options. Okay, so here's how we can get a few other points. For h of x, if you plug in x equals 3, I pick 3 because of this factor piece here. 3 minus 3 makes 0. And if you get 0 out of one of the parentheses, 0 squared is 0. 0 times whatever this stuff is going to be 0. So we know that it has to cross at 3, 0. And then you can spot it here. If you plug in a 1, 1 squared is 1. 1 minus 1 makes 0. And if you plug in negative 1 here, negative 1 squared is positive 1. 1 minus 1 makes 0. So we know it's going to cross at 1, 0 and at negative 1, 0. So let's see if that's enough for h of x. It's going to have a dot somewhere down here, so that's possible. A is out, okay. B is possible because it crosses at negative 1, at positive 1, and then at positive 3, just like we just said. So B is an option. C is not an option because it doesn't cross at negative 1, doesn't cross at positive 1, doesn't cross at 3. D is not an option for those same reasons. E is not an option. So we got a winner. H of x has to be B because of those 3 dots we have. None of those other graphs work. Okay, like A works. It crosses at negative 1, at 1, and at 3, but it doesn't cross at that y-intercept of negative 9 that we found. Okay, and sometimes when it all hinges on that one point, I like to double check. But if you plug in 0, you get negative 3 squared is positive 9. 0 squared minus 1 is negative 1. 9 times negative 1 makes negative 9. So yeah, it's got to be B for h of x. So let's go figure out f of x, see what else we can rule out. You could try just trying to find some other points for f of x. Like if you plug in x equals 1, see what it spits out for y. So 1 to the third is 1, and then put a negative sign in front of it, gives you negative 1. And then 1 squared makes 1. 4 times 1 makes 4. So if you plug in positive 1 here, you should get out positive 3 for a y coordinate. So 1, 3 should be a dot. Excuse me. So we said it's got to cross at the origin. And it's also got to cross at 1, 3. So this one's out, doesn't cross the origin. This one's out, doesn't cross the origin. 1 crosses at the origin, but 1, 3 isn't an option. So C is out. Cross it at the origin. 1, 3 is possible because they didn't label the y-axis. 1, 3 isn't happening here, so we know this has got to be D, okay? Because that's the only one where it crosses at 0, 0 and at 1, 3. So it's really about plugging in those points. And so it's okay to use technology. So we go to Desmos. And if you type in the functions, what do we got here? So f of x, just type in negative x to the third plus 4x squared, and Desmos knows you want a y variable to be happening on the other side. So you can see it can graph both of them for you, and those graphs should match up with what we just chose for them, right? I just plugged in fx as the red one in Desmos, and that matches with, let's see, what does that look like? Looks like graph D, right? Um, None of those other graphs look like what we have in red in Desmos. And then same thing for h of x. That's graphed in Desmos here in blue. And if you check here, you can actually just delete it now. We know that one. H of x, when you graph it, that's matching. Let's see. Which one does that closely resemble? Looks like that's matching up with B. Is that what we chose? Yeah. Yeah, so if you look at graph B, the general shape of it, and it looks different because they have a different interval for their y-axis, but still does the same type of thing. It goes down and then up in the same places.